Welcome to Superior Science's first ever live science show. So we hope everybody's doing well and staying safe. So before we just do a quick introduction, so my name's Isabella, and then we have Michael. You just want to give a wave. He's the other director.
Hi.
And then Michaela, Katie, Stas, Alexandra, and Amy. And today we're going to be talking about chemistry. So you're going to be seeing some cool demonstrations, and then you're going to be able to participate in making slime. And basically chemistry is the study of properties of matter and how they interact with each other. So sit back, relax, and enjoy the show. Thanks. So we'll get started with Alexandra first.
Hi everyone, I'm Alexandra, and the first activity we're going to do today is make invisible ink. So this is so we can write secret messages. We're going to do this 3 different ways today. Now the first way is using lemon juice. Lemon juice. So you're going to get a bowl, you don't need very much, and either a toothpick or a Q-tip or a paintbrush. Now, I used lemon juice, but you can also use vinegar or milk. Now, what you're going to do is you're going to paint a message or a drawing on your paper. And be sure, once you're done, to let the drawing dry completely. So we don't have time for that today, so I got one ready for us. Now for this part, make sure an adult does this part because using fire can be very dangerous. So I have a few candles here, and what we're going to do is hold the paper over top of the candle and see what happens. So you can also heat the paper using a hair dryer or a hot iron, or hold it near a light bulb, or warm it in the oven. So we're gonna keep heating it up, and as you can see, there's starting to be a design that's forming. Look at that. It's a smiley face. So you might be wondering, how does this work? Well, all the lemon juice is an acid. So is a milk, or so is vinegar. So the acid weakens the fibers in the paper, and then once the paper dries, the acid stays on the paper. So when you burn it, the part with the acid on it burns first and will burn brown. Cool stuff. Okay, our next technique is using wax. So we're going to get another sheet of paper, and we're going to take a white crayon. And with your white crayon, you can write anything you want. So we're going to do. Okay, so keep writing, and in the meantime, I'm going to grab. I have one ready already. We're gonna grab some watercolor paints. Some water Perfect. And a paintbrush. And we're gonna take some water and wet our paint. Then once we've got our wax message, our crayon message on our paper, we're going to cover, turn it around. We're going to go across the wax and see what happens. Whoa! So how does that work? Well, crayons are made of wax. Wax is a type of lipid or a fat. And wax is water insoluble, which means it does not dissolve in water. When something repels water, we call it hydrophobic, which means fear of water. Now, this wax allows it to function as a water repellent on the leaves of some plants or on feathers. So here the watercolor paint will not stick to the white crayon drawing and your message is easily visible. Cool! Our final method is using baking soda and grape juice. So what we're going to do, kind of like the first one, you can use a Q-tip or a paintbrush. And what I've done here is I've taken some baking soda, the same thing you use for baking cakes and baking, and put it in a bowl with a little bit of water. And then make sure you mix it up a lot with your paintbrush. Then you use your paintbrush and you can write a message. And just like the first one, you need to make sure it dries completely. Then, once it's dry completely, see, we can't even see what I might have written on this paper. So now what we're gonna do, we're gonna take our grape juice, rinse off our paintbrush, and we're gonna paint over top of the baking soda and water. You can use a sponge or a cotton swab, whatever you have at home. Come closer. So as we can see, it says science rocks. So how did this one work? Well, the baking soda is a base and it reacted with the grape juice, which is an acid, to produce a different color on the paper. So that was the 3 different ways to make invisible ink. Hopefully you can try them at home and they'll work just as well as they did today. Thanks for watching.
Okay, perfect. Thanks, Alexandra. So now we have Stas. He's going to be showing us a cool reaction with Red Bull, Coke, and milk.
And actually, just before Stas starts, I just wanted to let everybody know that we saw that the stream crashed on Facebook for some reason, but we restarted it, and hopefully it'll continue on with this going forward. But if we have any technical difficulties, just bear with us.
Okay, hey guys, so like Bella and Michael said, I will be doing a reaction with just regular old Coca-Cola, some Red Bull here, and then this is sugar-free, but it doesn't matter. If you have normal Red Bull, it'll work just great. And milk, whole milk works best, but we didn't have that in the house, so we're gonna use 1%. So basically the whole way that this reaction works is based on kind of what Alexandra was doing. It's called acid-base chemistry. So I don't know if you guys can guess, but in this reaction, the Coke and the Red Bull are something, they're acids, right? So lemon juice would also work, but we need the carbonation, which is the CO2 that's inside these specific drinks for this reaction. And then the milk, because it's creamy and it doesn't have a very sour taste. Milk is very kind of bitter and creamy, right? So that's the base in this reaction. So it's pretty quick, but the reaction works best if you let it sit for a little bit. So just see here. Oh, wait, I'll just hold it up to the camera. So as you can see here, I have just a normal glass. So now I take the Coke, pour it in a little bit, about a quarter of the way, a third of the way is good. Then what you're gonna wanna do is grab your milk. Now, when you pour this in, milk is actually a source of protein. And the specific proteins in dairy are called caseins. And right now, nothing's happening, right? It's just a clear liquid. If I grab a spoon and start playing with the liquid like this, nothing really, still really liquidy, I guess, for lack of a better word, right? But now, if I grab the Red Bull here, the caffeine, the carbonation, and the acid in the Red Bull causes all these proteins in the milk, the caseins, to clump up into something called globules and makes them globular proteins. In medicine, it's actually the opposite of drugs that we use called anticoagulants. So if someone has a blood clot, you give them an anticoagulant so that it does the opposite of what this reaction would do. So if you put the Red Bull in a good amount, this might be really hard to see, so I apologize for that in advance. So as you can see, if you can see that, now there's little stuff starting to form. That's actually the proteins in the milk starting to clump up. And if you leave it for long enough, so we're not gonna have time, but if you let it sit for minutes, the proteins actually start to separate towards the top of this glass, and you'll see a difference in layers because the proteins are less dense than the rest of the acids and bases within this. So can you guys see all those? So there's tons of these in milk. There's millions and billions of proteins in here. And now they're all separated inside. So it's just 3 things. Try it at home. Please, I swear, do not drink this. It's gross. But yeah, for sure. Acid bases, casein, good stuff. Try it at home. Thanks, guys.
Okay, perfect. Thanks, Stas. So next we have Michaela, and she's going to be putting out candles with carbon dioxide.
All right, hi everyone. I'm Michaela, and I'm going to show you how to put out candles using carbon dioxide gas. So we're going to make our own carbon dioxide gas for this experiment today through a chemical reaction between baking soda and vinegar, which most of you have probably either seen done or have done before using it in a volcano experiment. During that reaction, though, the product is carbon dioxide gas. So we're going to try and capture it and then dump it onto a candle, and you'll see that the candle flame goes up. All right, so to start the experiment, we're going to take a container here like this, and we're going to put some baking soda in it, just baking soda that you have in your kitchen. And we're going to put some in there. And then to start the reaction, we're going to add vinegar. And as you can see, there's bubbles forming, so that's evidence of a chemical reaction. And we're going to pour the carbon dioxide gas into this glass here. So carbon dioxide is heavier than the air, so it'll sink to the bottom of the glass. And then once the reaction is over, I'll take my candle and I'll dump the carbon dioxide, and the candle just goes out. So the carbon dioxide, as I said, is heavier than the air. So it sinks to the bottom of the glass, and when you pour the glass, the CO2 molecules will replace the oxygen molecules. So we're going to do it again, but with a bigger candle. So we're going to use the same pitcher. We're just going to add more of the reactants. And then we're going to catch the gas again in the glass. And make sure we have our candle light lit. And the candle just goes away. So I hope you enjoyed the experiment, and that's all I have.
Okay, awesome. Thanks, Michaela. Now we have Amy, and she'll be doing an experiment with Skittles and water.
Hi everyone, so I'm going to be doing, like Bella said, an experiment with some Skittles, which you probably have around your house, or you could also use M&Ms or any kind of candy with a coating on it, and some water. And so I'm just going to flip my camera so you can see what I'm doing, but what I've done is just laid out my Skittles in a little circle here, make sure that the same colors aren't together, and you can do this any kind of pattern you like. And basically we're going to be seeing what happens when we put water on the Skittles. And you can take a moment and think, do you think that the colors are all going to blend together? Are they going to be separate? Is it going to blend together after some time? And you can just take some time and think about it while you're looking if you have Skittles. All right, so now we're going to pour the water over our Skittles. And you want to make sure you have enough water on the Skittles. And then we're just going to wait a couple seconds before. As you can see, the color is starting to come off of our Skittles. And while that's going on, I'm just going to explain the science behind it. So the process that's going on right now is stratification, and each color of Skittle has a slightly different chemical makeup. And when it dissolves, this creates a water solution that has different properties in its density, salinity, and oxygenation. And this creates a barrier that prevents the water from mixing. And this is the same kind of process when you think about salt water and fresh water and why salt water and fresh water can't mix. So I kind of moved my Skittles a bit with the water here, but as you can see, like the colors are staying in their own lines to make kind of like a rainbow. And then after some time, if we just leave our Skittles here, it'll probably show it in a couple more seconds. Over time, the colors will start to blend together. And this is due to another scientific property that's called concentration gradient. And basically, this is just the process where molecules will move from high concentration to low concentration. And this is what's happening when we see the different colors moving over into each other. And yeah, so go ahead and make all the different kind of Skittles arts that you want. And that's all I have.
Okay, perfect. Thanks, Amy. And last but not least, we have Katie, and she's going to be making slime. So if you guys want, if you have this stuff to make slime, you can make slime with us, or you can just watch it and you can do it later. Totally up to you. So go ahead, Katie.
Hi guys, I'm Katie. So today I'm going to be teaching you how to make slime. So this is going to be like our take-home activity for the night. So before we get started, we're going to talk about the properties of liquids and solids. So when you look at these two different things, there's obviously some like properties that make the two different. So if you're looking at a solid, for example, its particles are packed really, really tightly together. There's not very much space and we can't see them moving. So these are what make it a solid, because this will keep it in its shape, it will keep it stationary. And this is like essentially the coldest state of matter that something can be in. And then if we have a liquid, this is like kind of in the middle in terms of temperature. So the particles aren't nearly as tightly packed together. So there's a little bit of space, they're moving, they're bumping into each other, and they can kind of flow. So if you're looking at slime, this is a little bit different. So when you see slime, it's almost like a mixture between like a solid and a liquid. So like sometimes we'll call this like a sliquid almost. It's kind of like a fun term, but it just means it has properties of both. So this can also be called a non-Newtonian fluid. So what this means is that it can appear almost solid when there's like pressure applied so that it'll stay like stable. So that's like how, if you've ever played with like oobleck, when you like hit the oobleck, it won't move and it will just stay stable. So that's like the properties of a solid. But then also if we take the slime and if we pour it into a container, it will fill the container. So then it would share the properties of a liquid. So another thing that's also interesting here is that when you play with them, it's a little bit different from like normal states of matter because you can also kind of change the state through like pressure or tension, whereas that doesn't normally happen if you have like ice or water. So we're gonna start making slime. So the first thing you're gonna do is take some glue. So we've discovered that like the Elmer's glue is the best. This is usually what we use in camp. So it's kind of, here, I'll put it down just a bit. So I don't usually do this with like direct measurements because it's kind of something you have to play around with. But so I've just put some glue in there in the bottom of my recyclable container. And then next you're gonna add some Tide. So I have a big bottle here. So I'm just gonna add some and then show you guys what I'm adding. So I usually add like enough Tide to cover the glue. It's kind of hard to see, but there we go. So then you're gonna take like a spoon or whichever you have, a popsicle stick will work too, and you're just gonna start by mixing it. So as I'm doing this, you'll notice that the glue will kind of start to become coated in the Tide. So this just means that it's like kind of making it to that transition of being like a non-Newtonian fluid. So it has properties of both solids and liquids. And so at this point, this is where it kind of gets messy. So this is why I have my lab coat on and why I have my hair tied up. But you're gonna want to take it out and start mixing it with your hands. So this is usually like the easiest way to do it, because then you'll be able to like incorporate everything, because sometimes the spoon just really isn't enough. But so yeah, so basically you're just gonna keep stretching it out like this. So as you can see, it's getting all over my hands. But another thing that's important to notice too is that it does have some like solidity to it, but it's also dripping, if you guys can see that. So it's starting to kind of form into slime. So as you can see, mine is still pretty sticky. So I'm gonna take some of like the leftover Tide that I have in the bottom of my container, and I'm just gonna keep mixing that in. So it does take a little bit. It is pretty sticky, so you're gonna wanna be sure that you have your area prepared before starting this. But so, yep, you're just gonna keep mixing it. So it's slowly starting to come together more, but it's still a bit sticky. So I'm just gonna keep adding more and more Tide by like dipping it into the extra Tide and just slowly working that in. And then also, if you would like to make it a different color, you can also add food coloring. So I'm gonna do that in just a little bit here. And you can also add like any gems or anything else that you want to kind of like personalize it. But so as you can see, it's like less sticky on my hands, but it's still like, we still need just a little bit more Tide. So then I'm just gonna keep mixing. And it also works in the opposite way. So if you've accidentally added like too much Tide and it's like not sticky at all and it's almost like breaking every time you touch it, you can also just try and add a little bit more glue, and then that will make it more of like a fluid consistency kind of. Okay, so as you can see, it's getting more solid. So now is a good time to add the colors. So I'm still a little bit messy, but that's okay. So I have my colors here. So I think I'm gonna do purple this time. So, oh, it's gonna come out. Okay, there we go. So I'm just gonna take my purple food coloring and just add like a drop right in the middle. That's all you should need to start with. And then you're just gonna wanna mix that in. So just be careful, because sometimes it will get like a little bit on your hands. So if that's something you wanna avoid, you can always just wear gloves or like ask for help or put it in like a baggie even when you mix it, because we've tried that too and that will also work. But so as you can see, it's like almost there. So I'm probably just gonna add like a little bit less of like Tide here. So this is probably like my last addition. And I'm just gonna keep mixing it. Okay. You'll know that it's ready once it starts to like pick up the other excess stuff you have left on your hands, if that makes sense. Okay. So I'm just gonna finish mixing this here, and then I'll show you guys what it's like. Okay, so as you can see, it's starting to like pull the stuff off my hands more than it's sticking. So this means that it's ready. So here's my final product. It's some slime. So I'm thinking we will probably attach the link to the write-up on when we post this on YouTube as well. We also have it on our website, so you can also check it out there. And then that will have like all of the instructions I used if you'd like to recreate this at home. But so yeah, so now you have your non-Newtonian fluid, which is slime. So thanks for watching, and Bella, back to you.
Okay, perfect. Thanks, Katie. So Stas just wants to show what his reaction now looks like after about 5-10 minutes. So Stas, if you want to show them.
Hey guys, just real quick again. So like I said, sometimes these reactions can take some time. So because this is an organic reaction, it usually takes longer. So as you can see here, this yellow stuff in the middle is just the actual liquid part of it. And now that the reaction has had some time to settle, you end up with this sludge at the top. And that's actually all the proteins that have clumped together from the acid-base reaction. And they're all the proteins in the milk. So yeah, that's it.
Okay, awesome. Thank you. So we just wanted to thank you guys for joining today. We're going to be posting this video on Facebook and YouTube tonight. And also don't forget to subscribe to our YouTube channel and like our Facebook page so you can be updated on what's going on. And yeah, that's about it. Thanks, guys.